Get RF analysis power in the palm of your hands with our new full-featured real-time USB spectrum analyzer.
Hello, this is Frederick from Tektronix. I'm going to give you some ideas and new inputs how to use the RSA306, which is one of the best-selling products we have in Nordic at the moment. For those of you who don't know what it is, it's a portable real-time spectrum analyzer who gets the power out of USB 3 and it converts RF to USB 3 bursts. So what is the real-time spectrum analyzer all about? So we go for preset here again, and I'll show you. Let's go to a band which we all know, 2.44 gig. We go down with the ref level a bit. You can see here, normally you go to enable peak hold, and this is the standard way of doing it. This is when the IQ data is stored in a memory buffer for them to do some extra measurement. But in some cases, you want to have the same feeling as an analog scope. You don't really need the fundamental data. You just want to see, be able to do some simple measurement. And this is what the DPX can do. So from this window, I just go to the DPX, and that's it. So the DPX, instead of sending this IQ data to memory, it sends it to a kind of a pixel matrix. And when we do the FFT, we count the numbers of hits we get on each pixel. And behind every pixel is a counter, a timer, and a resetter. And I can control those. So let's clear this one and clear this one and see which one gives the most insight. And I think it's clear that this one hasn't even spotted this one yet. And there's also some larger bursts from time to time coming up. So if you want to see this a little bit more, I will spend a few minutes just showing how you can tweak this. So first of all, you go input traces. You go into the trace. I need to go to the right window. Traces, trace bitmap. And I put the variable persistence to 5 seconds. So it means that the timer will reset all the data after 5 seconds. I get the signal there a little bit longer. I auto color the bitmap scale. And this is basically what I do. So we can clear again. We can clear again. And here you are. So one question I got from a customer, oh, it's really nice, but I mean, it's nice to see this colored thing, but sometimes I just want to see the peak values, for example. How can I do that, in a very easy way? Yes. Do like this. Enable trace 2 here, and remove trace 1. So this is the DPX max function. So if I clear this one again and I clear this one again, you can see which one, builds the fastest. In some cases, some people want to do this. So they have the envelope or the bitmap pixel, but they still have the envelope of the max hold here. This is a good function. So this was just an easy signal. Let's go to something a little bit more complicated that turns everything upside down. Let's go to LTE uplink. It's a very special signal. So 2508 meg we have it here, and this is how it looks. So how can I enable this a little bit better? I tweaked a bit already by enabling trace 3. If I remove like this, it's not that visible what's going on here with the signal. So this is where you tweak it by enabling trace 1 and remove bitmap. And here I know the channel bit. You need to go down to like 100, and now you can see the individual bursts. This is a typical thing. And this one, if I clear this one and I clear this one, I mean, it's such a difference. And if you want to know exactly what we're doing here, I can go here to preferences and show a parameter readout. So I can see the POI in this case is like 3.5 milliseconds, it goes up and down. But this one I can do the same. They call parameter readouts, and it's like, depending on the PC what's doing. So one, it's 100 milliseconds, 93, and this is, milliseconds. So this is really what you can do with this insight. Of course, there's availability to trigger, etc. But most cases, you just want to look at the signal. And there's multiple ways you can do it using our real-time spectrum analyzer function. So let me walk through this again the last time. So this. I can show 2, which is a max hold, the envelope, or I can also enable the bitmap. The bitmap is really good in certain cases where you want to see signals under signals. So if you assume there is a signal somewhere which is in 2 states, you can clearly see that, for example, in transmit and receive. And you can see some signs over here that it's sometimes in 2 different power levels. I hope you find this interesting. It's a short video.
Get RF analysis power in the palm of your hands with our new full-featured real-time USB spectrum analyzer.